So here we have some of the instructions along with which bit we can use. Okay, say the first instruction is going to be CLR. CLR stands for clear. Okay, in here CLR, either a C can be written, C is a carry bit, or directly the address of the single bit, whatever the direct bit is there. Say like even if I take the register P0 register, okay, P0 register is a port 0 register. Okay, so if port 0.0, I can write port 0.0 here. CLR port 0.0, which will make a port 0.0 pin is there no on the hardware pin, that will be made 0. That pin will be made, that means I am sending 0 upon that, sending or receiving, whatever it may be, but upon that pin I am making it clear, I am making it 0. Whether it may be P0.0, P0.1, P0.0 to P0.7, P1.0 to P1.7, whatever, but I am modifying a single bit. As well as there is a bit addressable memory from 20 to 2F, total 16 bytes are there, correct? That also we have seen in the RAM organization, correct? We have 16 bytes where a single bit of 16 bytes can be accessed. The address of this 20H, the 16 bytes are from 20H to 2FH, correct? This is the address, and in that 20H, the address of first bit is going to be 00H. Okay, 00H. So if I write CLR 00H, it means a particular bit. Then this bit of the 20th memory location, 20 memory location, bit 0 is going to be made 0 by using CLR instruction. Okay, so in that way also I can write, either I can write a carry flag or I can write bit, a bit, direct bit, the address of the bit or the individual bit of the register. Okay, so the here the total number of bytes it is going to take it as a single byte, it will be storaged occupied in the memory location when it is clear C. When I am writing a particular bit, then it will take a total 2 bytes to be stored into the memory, code memory. Then it is taking only one machine cycle to be executed. Then we have set instruction. So set, if I say set, then that particular bit is going to be made high or logic 1. Logic 1. Okay, so set C, it means carry flag is going to be modified or set to 1. 1 is written into the carry flag, or set a particular bit. So I can write an address of 20H to 2FH, or I can write any of the bit register, bit accessible register in the place of bit. So we are going to write 1 upon that bit, right? Clear is going to make it 0. Set is going to make it high 1, logic 1. Complement C, CPL stands for complement. So here what will happen? C will be loaded with C bar. It means if it was 0, then the carry flag will be updated to 1, and if it is 1, it was 1. Now after this instruction, the carry flag will be made 0. Okay, so it is going to be complemented. So it is similar to any of the bit, as I have given an example here, right? Then ANL. ANL is AND logic, right? This one already we have seen, but again, ANL is AND logic, but it is going to perform upon a particular bit. It is going to perform upon a particular bit. Say C is having, it may have a 0 or 1, then this is going to be the complement of the bit. It is going to be a complement of the bit. Then that particular bit is going to be complemented first and then ANDed with C, and then the result is stored into C only. C is going to be updated. So if C was 0 and bit was 0, bit is going to be complemented. It will be made 1, and 1 into 0, again it is going to be 0. C will be again stored with 0. Okay, if C is 1 and bit is 0, bit was 0, now it will be complemented, it will be made 1, right? So 1 is going to be stored into the C only. So it is AND operation between the C and bit bar. If I don't write a exclamatory sentence here, right? Here, if I don't write not exclamatory, what is this? What is the symbol? What is that? Bar, forward bar or backward, something it's called. Okay, I have forgotten. So it is been forwarded. A bar bit, it means the bit is going to be complemented. If I don't write that bar, then a direct bit. If it is 0, 0 is going to be ANDed. If it is 1, 1 is going to be ANDed with C, and the result is stored into C only. Okay. Then in the same way, we have ORL. ORL, C comma hash, a bar bit, then C comma bit, either complemented or non-complemented bit. It is going to be made OR logic. Then move bit comma C, bit comma C, or C comma bit. It means the bit value will be updated towards the carry flag, and carry flag is going to be loaded into a bit field. Then basically these are the branch instructions, but it is been also included into Boolean expressions. We will see that. J stands for jump. J stands for jump. And JC stands for, this is one condition now. JC. The jump is going to happen only upon the status of carry flag. Okay. Related address. So whatever the address is there, that is going to be written here. Relative address. REL stands for relative address. So here C is a condition. J is a jump. Jump if carry flag is present. Jump if carry flag is set. It means if C is equal to 1, then jump instruction is going to be executed to a particular relative address. Whatever the address I'm going to give into the program, that for that address, the PC, that is ALU, is going to jump to that address. But what is happening? It is checking for the carry flag. It is checking for the carry flag. Okay. Then JNC, jump if no carry to the particular relative address. Okay. Address we will see in-depth working of this jump instructions in the further slides. But now the jump stands for making ALU to transfer from one location to another location, and that another location is related address. So ALU is jumping to relative address directly, but it is depending upon the condition of carry flag. So JC stands for jump if carry is set. Jump if carry is set, and JNC stands for jump if carry is not set. It means C should be equal to 0. Then only this instruction is going to be executed. Then again JB, jump if bit. So which bit, that we have to specify here. So if this bit is equal to 1, jump if bit is set. If this bit is equal to 1, then the ALU is jumping to a relative address. Then JNB, it means if a particular bit, what I am mentioning here, what I am writing here, if that is 0, then only the ALU is jumping to a particular relative address. Okay, bit is equal to 0, then it is going to be jumped. Then JBC, so jump is happening if the bit is set. JB, jump is happening if the bit is set. If particular bit is equal to 1, then only jump is happening. So after jumping to a relative address, the particular bit is going to be made 0. Clear. C stands for clear. It is not a carry flag. Here JBC, C stands for clear bit. Clear a particular bit. So jump if direct bit is set and clear the bit. Okay. So hope all these instructions are understood. Is it understood? You will see some examples here. So clear. Clear C, which stands for clearing C carry flag CY is equal to 0, or P1.1. It means P1 is a register of port 1 register. Into that, a particular P1.1 is going to be made 0. Okay. Set bit A.2, set bit C. A is accumulator register, right? A is an accumulator register, and dot 2. It means second bit 0 and 1, A0, A1, A2. The third bit is going to be set, and here carry flag is equal to 1. CY is equal to 1. Then complement CPL. Complement a bit. So CPL 40H. 40H is the memory location, address memory of the bit addressable. A bit addressable memory. 40H is present in the bit addressable memory. Okay, if you go back to a memory organization, RAM memory organization, from 20 to 2FH, there are different memory addresses. A single bit is having different memory address from 00 to 7F. So into those, the 40H bit is going to be made complement. If it was 0, it will be made 1. If it was 1, it will be made 0. Okay. Then ORL, move. These are some examples as we have already discussed. Okay. So 20H is going to be a particular bit address. Bit address. It is not a byte address. It is a bit address. 20H. Okay. and that bit is going to be OR gated, OR logic with C, and C is going to be updated. Here 34th bit, 34H, it means 34H address of a single bit, that is going to be first complemented, and then it is going to be ANDed with C, and then the result is going to be updated into the C only. 3FH, so it is an address of a single bit, not a byte address, that is going to be transferred into the carry flag. So here the carry flag is going, the value of carry flag is going to be updated toward P1.2. Okay. JC, JNC. So they are same as we have already discussed. Then we'll move for jump instructions, branch instructions, branching instructions. So which are basically used for jumping from one memory location to another memory location. Say I have 10 instructions in a single program. I have 10 instructions in a single program. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. I am executing the first instruction. Okay. Second instruction is going to be executed. Third instruction is going to be executed. When it comes to a fourth instruction, I have to, after the third instruction, I have to execute the seventh instruction. Then in the fourth instruction, what I will write? Jump to with condition or without condition. Okay, with condition or without condition. Jump to a seventh location. So processor will do a jump to a seventh location. It will execute the seventh instruction. It will execute eighth instruction. After eighth instruction, I have to go back to the fifth instruction. So I will write a jump instruction here. So the processor will jump to a fifth instruction to here. So fifth instruction is going to be executed. Sixth instruction is going to be executed. In the sixth instruction, what I will write? Jump to a 10th instruction. So again, from this, I will jump to a 10th instruction. Okay, so 10th instruction is going to be executed. So what I am doing, I am modifying, or I am changing the flow of execution of the program. The flow of the execution of the program is controlled by these jump instructions. So I am controlling the flow of execution of the program. So that is controlled by the branching instructions. The flow of the program is controlled by the branch instructions. Okay, so what are the instructions I have? Say, for example, I have, so first we are going for unconditional jump instructions. So I have two types of branching instructions. One is based upon a condition, and another one is based upon uncondition. So there is no need of condition. Directly the branch is going to happen without any conditions. Say if I put any condition, then that is going to be considered as a conditional jump instruction or conditional branch instruction. Okay, so let us see some examples over here. Let us go for unconditional jump first. So first I have short jump. Basically, it provides 4 different types of unconditional jump instructions. There are 4 instructions now. Okay, 4 instructions. One is SJMP, short jump. Short jump stands for, it is an 8-bit signed offset relative. So relative address is there, no? Relative address, what I told, offset relative address. I am going to give a particular memory location or address where the processor have to jump. Okay, so if I use SJMP, the particular address what I am going to give, that address should be a signed address. It means only a single byte address. Single byte address means 8 bits. Out of 8 bits, the MSB is going to be either a plus or minus, and I am remaining with 7 bits. I am remaining with 7 bits. So what is 2 raised to 7? What is 2 raised to 7? What is 2 raised to 7? Don't know. Is it not 128? So I have 1 plus 127 up to 0, then minus 128. So this 8th bit is going to be the sign, okay? 8th bit is going to be the sign. If it is 0, then the address is positive number, positive address. If it is 1, then the address is negative address. So it is going back for the negative address, and it is going forward for the positive address. Okay. So total 8-bit signed offset address. We are jumping, the processor is jumping, the processor is taking a short jump to a particular relative address, and that address is going to be, 8-bit address. And that 8-bit address, that is going to be a signed address. So only I can jump from 0 to up to, if I'm standing here, if the ALU is standing to a 0, it can jump to the backward. It can jump to the backward of up to minus 128 addresses. Minus 128 addresses, or it can jump up to plus 127 addresses. Anywhere between 0 to 127 addresses, anywhere between 0 to minus 128 addresses. Okay, so it is a short jump. When examples comes, then it will be very easy to understand that. We will see examples also, right? So here SJMP is a short jump which is jumping for 8-bit 1 byte address, which is jumping for 1 byte of the next instruction. Okay, then LJMP. So LJMP stands for long jump. So here we are jumping for 16-bit address. We are jumping for 16-bit address. So 16-bit stands for total what? 2 raised to 16 is going to be 2 kilobytes, I think. No, 16-bit address is going to be what? 2 raised to 16, 60, total 64 kilobyte. 64 kilobytes. Just give me a second. So here only yeah, 65,536. 65,536 stands for 64 kilobytes. Okay. We are remaining with only 6 minutes. So after this session, please join again. Okay. So total 64 kilobyte. We don't have that much of the memory space into our 8051, but still, if we connect an extra memory for 8051, then we are able to jump for this memory location, up to this memory location. Okay. So LJMP will help us to jump up to 64 kilobytes of memory address. Anywhere between 64 kilobytes. Anywhere between 64 kilobytes. Okay. See, it is been written here. Entire 64 kilo of program memory. Right? It is like LJMP and SJMP is local. SJMP is going to be a local. LJMP is going to be what we can say STD. So these are unconditional jump. When I execute SJMP and particular address I have to write here. Say I can write a 20H or one that doesn't do. Okay. This is a local jump only for 256 bytes, and this is STD jump for up to 64 kilobytes. Then another two are AJMP. Okay, here is the we will see this one only. It will be very easy. So here what we have seen LJMP, and we have to write the address. Then SJMP, the relative address. Okay, short jump, long jump. The address is going to be total 60. Okay, sorry for the delay. So we have seen LJMP, SJMP. Then, okay, actually what will happen whenever we write this address now, that address will be loaded into PC. PC stands for what? Program counter. What is the meaning? So whatever the program counter is having the address, whatever the instruction is being stored into that address, that instruction is going to be executed by the ALU. Right? It will hold the address of the next instruction which has to be executed. So this new address will be stored into PC. That is why ALU will jump to the PC. Wherever the PC is locating to the address, into that address, the ALU will go. And whatever the instruction is present inside that address, that instruction is going to be executed. Okay. If it was offline class, no, there are so many examples I can give you on the board. I can write on the board. It is quite difficult here to write upon this. And to make you understand, it is quite difficult for me to make you understand. Hope whether it is understandable that much or not, I don't know. But still, I am trying my level best. Okay. If you have any other doubts or if you are really not understanding, you can ping me separately, individually. We can make discuss and we can clear it. Okay. Don't hesitate to ask the questions. So join back. I will just end this meeting and let us join back. Everyone have to join. Okay.